Hi, welcome to AhaGuru question types for JEE and NEET. Today we are going to look at a very important question type based on Gauss Law for electric field. There's also Gauss Law for magnetism, but here we are focusing on Gauss Law for electric fields. And there are many types of questions that will be asked in Gauss Law, and we are going to focus on one very important type of question that is asked very often in the JEE as well as NEET. Let us now look at some of these examples. You can see that just in 2025, so many different questions based on Gauss Law was asked. Again in 2024, you can see quite a few questions were asked based on Gauss Law, right? So this question is telling you that there is an infinite line charge. The density is given. Find the net flux through a Gaussian cube. Okay, how do we solve such a question? For this, we need to understand Gauss Law, right? Every question here is actually just one or two steps. If you understand what Gauss Law says very clearly, then you can solve it. So let us now look at Gauss Law a little more carefully so that we can quickly answer all of these questions very, very easily. Let us start. If I have a bunch of charges like this, okay, some plus charges, some minus charges, it doesn't matter. So Q1 is here, Q2 is there, Q3, Q4, Q5, Q6, Q7. Now if I take any point, let me pick a point here, the electric field is going to be because of all of these charges, right? Q1 will produce an electric field, Q2 will produce some other electric field like that, Q3 will produce an electric field, okay, Q4 will also produce an electric field, let's say like that. Q5 is going to produce an electric field like this, negative charges, electric field is pointing towards the charge. Q6, Q7. Now, if you add all this up, there will be one net electric field, let us say something like that or something like that. You're going to get a net electric field. At this point, if you take another point, there will be a different net electric field produced by all the charges. Now, what does Gauss Law say? If you take a closed surface, this is three-dimensional, okay, it's closed surface, so it is this way, that way, you have to think of it like that, closed surface. If you take a closed surface, at every point on the surface, there's going to be an electric field produced by the charges outside, the charges inside, everything together, okay? They will all together produce an electric field. So suppose I take this point, at this point, Q1 is going to put an electric field, Q2 will put an electric field, Q3 will put in an electric field. So you have to add up all the electric fields. Let us say the net electric field is going to be pointing that way. Okay, this is the net electric field. Like that, at every place we are going to have net electric field, right? So if I pick this place, a small area, let us say that the net electric field was pointing in that direction, and let us call that E1. Now you can take E1 dot this area vector. The area vector is going to be pointing like this. This is dA or ds, okay, or ds vector. People usually use S for area. So ds vector or dA vector. Now just like I did there, I can take another place and I'm going to get some other electric field. Now remember, E2 is produced by Q5, Q1, Q2, Q3, everything. All of them together produce E2. Now E2 dot this area vector. This is the area vector. That will give you the flux through this tiny area, flux through that tiny area. And I can do that for every point on the surface. This is three-dimensional. I'm going to do that for every point on the surface. E3 dot this area. Area means always take the area perpendicular to the surface. Take the area perpendicular to the surface. E dot ds vector or dA vector, right? So generally we use ds. So if I take E dot ds, E dot ds, E dot ds across the entire surface, that means I have to do an integral, that will be the flux through this closed surface. How much will that be? Well, Gauss Law tells us that this, right, flux only depends on the charges inside. These electric fields depend on the outside charges, inside charges, everything. But the flux only depends on the charges inside. So Q inside by epsilon naught. Q inside by epsilon naught. Now Q inside is Q1, not Q2, that is outside, right? Q1 plus Q3 plus Q4 plus Q6 plus Q7. Now of course Q6 and Q7, they are negative, right? So Q1, Q3, Q4, Q6, Q7. These two are negative, these three are positive. the total charge inside, the net charge inside divided by epsilon naught. This and this does not play a role in the answer. Of course, these play a role in E1, E2, E3. They all depend on all the charges, but the net answer only depends on the charges inside, which actually, if you think about it, is a very interesting law. Okay, so this is called Gauss law. So electric field is actually the density of lines, no? When you say, what is the electric field here? Well, it's actually telling you how many lines are passing through that. Similarly, this electric field is telling you the density of lines passing through this. So when you take E into A or E dot ds, right? If you take it, what are you getting? You're getting the number of lines coming out, net number of lines coming out. A line going in considered as negative, line coming out considered as positive. Okay, so the net number of lines coming out here, coming out here, coming out here across the entire surface. So electric field is the density of field lines. So that means phi flux is the net number of field lines passing out from the closed surface, coming out of the closed surface. Now how many lines will come out? All the lines that are produced inside. Well, what about the line produced here? Any line produced here will come in and go out. So once it will be counted as coming in, once it's going to count as going out. So any line produced outside is not going to matter because net effect is going to be 0. So only the net number of lines produced inside. Now this will produce some lines, that will eat up some lines. Some of those lines can go directly. So if you actually look at it, it is the net number of lines produced inside. So that depends on the total net charge inside. So net lines produced inside, which of course depends on the charge inside. That's why Q inside by epsilon naught. So this law tells you, while it is true that the electric field depends on all the charges, the net flux through the entire surface, the total flux through the entire surface only depends on the total charge inside. That's all. So the basic idea is that any field line produced by outside charges, the contribution becomes, net contribution becomes 0. The line can come in and then go out, right? Or if a line comes out like this, remember that this is going to absorb some lines anyway, right? But that line, generally if it comes from here and goes there, then it is not going to be counted. So any line produced outside does not matter. So outside charges do not contribute to the total flux through a closed surface. Only the inside charges contribute. Once you understand this, you can very easily solve every Gauss law question. Let us now look at this question that was asked in the JEE in 2024. There are 5 charges, 1, 2, 3, 4, 5, you can see that, plus Q, plus 5Q, minus 2Q, plus 3Q, minus 4Q, as shown in this figure. The electric flux due to this configuration through the surface S, this is the surface S, so let us mark this surface. Okay, so we want to find what is the electric flux through this configuration. Actually, once you know Gauss law, this is very trivial. Why? Because Gauss law tells us that the net flux through the surface, it's a closed surface, is equal to the total charge inside divided by epsilon naught. Right? Do I have to take care of this? No, it is outside. Do I need to worry about that? No, it is outside. We only have to worry about this. So what is the charge inside? Plus 5Q plus Q minus 2Q. Okay? So this is basically 6 minus 2, 4Q. 4Q. And so the answer is going to be 4Q by epsilon naught. That's it. So you can see it's just a one-step answer. And which one is 4Q by epsilon naught? Option D. And so that is the answer to this question. Now the electric field at this position will be produced by these 3 and these 2 also. The electric field here is going to be the result of 5Q, Q minus 2Q minus 4Q plus 3Q. The sum total of all these will be the net electric field at that location. Similarly, at this location, you will have the net electric field produced by every charge. Net electric field produced by every charge here, right? So basically, if you take any point, the net electric field will be produced by all the charges. But if you take E dot E dot ds. This is the flux, right? If you do an integral of this over the entire surface, then this only depends on the total charge inside. Okay, keep that in mind, and from that we can easily get the answer to this question, 4q by epsilon naught. The previous question was very, very easy, almost too trivial. In fact, most people won't even believe it is a JEE question. What about this one? This one is also very easy. In fact, Gauss Law based questions in JEE are mostly super easy. Let us look at this one, JEE 2025 question. So, an infinitely long wire, and in this question the big part of the problem is to draw the diagram correctly. Okay, that's important. An infinitely long wire, this is that long wire, has uniform linear charge density lambda, okay, which is 2 nanocoulombs per meter. That means for every meter the charge will be 2 nanocoulombs. The net flux through a Gaussian cube of side length √3 meters. So this is that Gaussian cube, this is √3, this is √3, √3, √3, right? Every side is going to be √3. It's a cube. Right? We have a Gaussian cube of side length √3 centimeters. We want to find the net flux through that. Okay. If the wire passes through any two corners of the cube that are maximally displaced. Now, any two corners can mean this corner, that corner, this corner, that corner. No. They have used the word maximally displaced from each other. What will that be? Well, it has to be the opposite vertices, right? So, if I pick this one, then I have to pick that one. Right? Not this, but that. So, if it's at the top surface there, then this has to be in the bottom surface, and it has to be body diagonally opposite, right? This is the body diagonal. So, the portion of the line inside the cube will be the body diagonal. It will be the body diagonal, right? If you see this, this is the body diagonal. Let me draw this. So, let us say from here till there. That is the body diagonal. Is that clear? So that is the total amount of charge from here till here. That is what is going to be inside. These charges are all outside. Okay. So basically the wire passes through the cube in such a way that it is basically from, let us say, A to, we can say B, C, D, etc. But I will just call this B. So AB length is what we need. And we have been told that the flux would be X Newton meter square per coulomb. So they have given it in SI units. And they want us to find out what is the value of X. So they have given you some options here. How do I do that? Well, the total flux is going to be the charge inside by epsilon naught. The total flux, right, through the cube is going to be charge inside by epsilon naught. Charge inside is basically this charge, no? This is all outside. So that has to be equal to lambda times this length. Let me call this length L. So lambda times L, that will be the total charge inside, divided by epsilon naught. Now lambda we know, 2 nanocoulombs per meter. So what do I need to find? I need to find this length. How do I find that? Let us see. So if I look at this, this is √3. This is √3. So this diagonal, right, let me draw this. This diagonal, you can easily find. This is a right angle triangle, right? This is a right angle triangle. So you can easily find this. √3 square plus √3 square will give you, right, this square, this diagonal square. But is that what we want? No, we want that. But this diagonal is perpendicular to this. This is also √3. So either you know the formula saying L square is equal to √3 square plus √3 square plus √3 square. Right? For the body diagonal, it is root of a square plus b square plus c square for any rectangular, like cuboidal shaped object, right? So if you take a cuboid, this is a cube. So it will be a square plus a square plus a square. So we can do that. Or you can derive it. You can say, okay, this is a right angle triangle. So this is √3 square plus √3 square, root of that. And then this square plus this square will give me L square. So either way, we will be able to say L is root of √3 square plus √3 square plus √3 square. How much is this? 3 plus 3 plus 3. 3 into 3. Right? This is 9. Root of 9 is 3. So L is 3. Centimeters or meters? That you have to be very careful. Root 3 centimeters. So this is going to be 3 centimeters. So 3 centimeters is 3 into 10 to the power of minus 2 meters. Remember everything in SI units. Why? Because they've given the answer in SI units. So that means this flux is lambda L by epsilon naught. L is this. Lambda is 2 nanocoulombs per meter. So let me just substitute all of that. So phi for the cube is lambda 2 into 10 to the power of minus 9. Nano means 10 power minus 9. Keep that in mind. L is this. So 3 into 10 power minus 2 divided by epsilon naught. We have been told 4 pi epsilon naught is 9 into 10 power 9. So I can multiply by 4 pi and here and multiply by 4 pi there, right? Anyway, we want the answer in pi. So I will say into 4 pi and 1 by 4 pi epsilon naught, okay, I don't have to write in the denominator, is 9 into 10 power 9. 1 by 4 pi epsilon naught is 9 into 10 power 9, right? So I can directly write that. So this is going to be the answer. Let us try and simplify. 10 power minus 9, 10 power 9 cancels. Okay, so I've got 9, 3, 2, 4. So well, how much is this? This is 2 into 3, 6. 6 4s are 24. So 24 into 9. This is what I have to multiply, right? 6 4s 24. 24 into 9, pi 10 power minus 2. So this is going to be 9 4s 36, 6, 3, 18, 19, 20, 21. So 216 into 10 power minus 2. So that means 2.16 pi. 2.16 pi in SI units. SI units will be what? Well, newtons per coulomb into meter square. So Newton meter square per coulomb. So if this is the answer, then this must be X. Is there an option like that? 2.16 pi? Well, you can see this is the answer. So option A. Was that difficult? No. All you have to do was to calculate this length, and lambda times this length will tell you the charge inside, and charge inside by epsilon naught will give you the flux through the cube. So that's it. Once you know Gauss law, you just focus on finding the total charge inside. You can ignore the charges outside, and that will then tell you how to get the flux through the cube. You can see Gauss law questions turn out to be extremely simple. Let us look at one more. Here is an interesting Gauss law question that appeared in the JEE in 2025. Okay, so here they've given us a cube. They've given us a cube of side length A. There's a cube A, B, C, D, E, F, G, H having edge length A as shown here. There is a line charge of length A by 2 that is kept at the center of one of the edges, BC. This is kept at the center. This is A by 2. The total one is A, and this is kept right in the center, right in the middle. Okay. If the density of the line charge is lambda, okay, so this density is lambda, this one is lambda per unit length, then find the total electric flux through all the faces of the cube. So basically the net electric flux through the cube. Can't I say length is A by 2, lambda, so the charge must be lambda into A by 2? Correct, you can do that. So isn't it that charge divided by epsilon naught? No, because this is not inside the cube. This is on the edge. So some of the lines will go this way. So they will all get counted, right? Some of these lines will all get counted. They'll all go through the surface. So they're all going to be part of the flux. But some of the lines will just go this way. Now they're not going through the surface. No, they're starting there at the surface and coming out. So you should not be counting that. How do I find this? What is the net charge inside? How do I do that? Well, there's a nice trick for this. You know that this is in the middle. So if I now take another cube and keep it this side, right? Just bring one more cube here, exactly the same size, then this lambda will be shared between this and this. But there will still be some lines going down. Then you put one more cube there and one more cube here, and to understand that I have here a better diagram. So you can see that this lambda is now going through that cube. There is one cube there. You can see that that is one cube, right? I'll just show you that cube. But then there is one cube in front. that is here, right, this cube. And then there are two cubes like this, one cube there and one cube in front here. Can you see that? This is that front cube. So basically that line has a cube there, a cube here, right? If I show it this way, cube there, cube here, cube there, cube here. So there are four cubes. Now this is fully inside these four cubes. But if you now think about it, this lambda, length a by 2, this charge, right, is symmetrically placed for all the four cubes. So whatever lines are coming out of that charge will have to go partly there, partly here, partly there, partly here. So each of the cubes will get 1/4. So flux through any one cube, right? Any cube. You can pick this one, pick that one, pick that one, pick that one. Of course, we want A, B, C, D, this particular cube will be equal to the charge inside, which is actually lambda into A by 2, divided by epsilon naught. Well, that will be for all the four together. So epsilon naught, 1/4 of it, 1/4 of it. So lambda A by 2 by, right, this charge inside is lambda A by 2 because the length is lambda, that is A by 2, divided by 4 epsilon naught. How much is this? Lambda A by 2 into 4, 8 epsilon naught. So the flux through this cube, A, B, C, D, right, E, F, G, H, that is the cube, right? The answer is lambda A by 8 epsilon naught. Lambda A by 8 epsilon naught is option D. So do you understand this? The lines coming out of that little tiny charge that you have there is not just going through that cube, it is also going through this cube, going through that cube, going through this cube. But because it is symmetric, you can say all these four cubes get the same amount of flux, same number of lines, and so each one will get 1/4. So flux through any cube will basically be 1/4 of q by epsilon naught, and so therefore the answer is lambda A by 8 epsilon naught. Lambda A by 8 epsilon naught, that is this answer. Now you have to keep in mind that these kinds of questions will be asked very often. You know one very common question, when you keep one charge q at one of the vertices, then what do? You cover that cube, right? You cover the charge with cubes everywhere. Then you say, okay, at the bottom I'll have 1, 2, 3, 4, top I'll have 1, 2, 3, 4, so you'll end up with 8. But in this case, because it's kept in the edge, you have only 4 cubes that you have to keep. That is a slight variation, a very interesting variation, and you must understand how to solve this kind of a question. The question that is usually asked, and that has been asked in the board exams huge number of times, and of course also in the JEE, and that kind of question basically keeps the charge here in one of the corners. And then you know, by now everybody knows this question, that you have to place a cube here, cube there, and also in the top, and so you know you have to place 8 cubes. But in this case, not 8 cubes. In this case, you have to place 4 cubes. Okay, notice this answer. If there are 8 cubes, many people end up saying, I know, I have to divide by 8. And if they divide by 8, lambda A by 2 by 8 would have given you this. But this is the wrong answer. Okay, so this is a small trick question. Don't use the answer or the approach. The same approach is what we are using here, but don't write the answer that you would have written for this question. This you have to think afresh. Let us now look at this question that appeared in the JEE in 2025. There is a point charge Q that causes an electric flux of -2 into 10 to the power of 4 Newton meter square per coulomb. So in SI units, notice it is negative. Okay, so this electric flux passes through a spherical Gaussian surface of 8 centimeter radius, centered on the charge. So this is at the center. Now if it was a positive charge, it's going to produce lines going out, but the flux then would be positive. But since the flux is negative, we know it must be a negative charge and the lines must be coming in. So I must have a line from here going like that in. I must have a line going like this from this side. Let's say this line coming from, I don't want to hit that cube, but yeah, like that, like this, right? So from all directions, you're going to have the lines coming in, right? So basically the lines are all coming in. Why? Because there's a negative charge. How do I know it's a negative charge? Because it's given that the flux is negative. If there's a positive charge, the flux will be outwards, and so lines will be going out, so it will be positive. Since it's negative, this I know must be a negative charge, so lines must be coming in like that. Okay, but it doesn't matter. We know that the flux, net flux through the surface must be equal to Q by epsilon naught. Q inside by epsilon naught, and what is the charge inside? Q. So Q by epsilon naught, this is negative. Now this must be, it's given. It is minus 2 into 10 to the power of 4. What is the question? Find the value of the charge. So Q is equal to epsilon naught into this. That's it. Very, very, very trivial, right? So Q is just this into epsilon naught. Epsilon naught is 8.85, 10 to the power of minus 12. Everything is in SI units. Into minus 2 into 10 to the power of 4. And since everything is SI units, this is going to be coulombs. The answer is going to be in coulombs. Now what is 8.85 into 2? 17.7. 17.7 minus sign is important. 10 to the power of minus 8 coulombs. So this is the answer to the question, right? 17.7 minus 17.7. This is just 17.7. No, this is not right. Minus 15.7, not right. Minus 17.7 into 10 to the power of minus 8. This is the correct answer. So the correct answer to this question is option C, minus 17.7 into 10 to the power of minus 8 coulombs. Let us now look at this question that appeared in the JEE in 2024. Okay, so here we have two cubes, C1 and C2, They are two hollow concentric cubes. So this is at the center of that cube, right? You can think of it that way. They enclose charges 2q, so 2q, right, is inside C1, and 3q is outside C1 but inside C2. They enclose charges 2q and 3q respectively, as shown in the figure. Find the ratio of the electric flux passing through C1 to that passing through C2. What is electric flux? The net electric flux passing through a closed surface, Gauss law. What does it say? Phi is equal to charge inside by epsilon naught, right? So we know the basic rule that flux net through a surface is Q in by epsilon naught. So you know this. So if I take C1, so let me call it phi 1. Phi 1 is for C1. So that will be the charge inside. Will 3q matter? No. Why 3q won't matter? Because it's outside. So it has to be 2q by epsilon naught. Right? This is for C1. This is for C1. What about flux through C2? Flux through C2. Should I say 3q by epsilon naught? No. Because if you take this cube, this is also inside, that is also inside. Well, that is inside C1. It doesn't matter. It's still inside. So therefore, the lines that come out of 2q, remember these lines that come out of 2q will also come out of C2, right? They'll come out of C1 and they'll also come out of C2. So you will definitely have to count 2q, and of course you also have to count 3q. So that means you have to count 3q plus 2q, and so it will be how much? 3q plus 2q by epsilon naught, which is 5q by epsilon naught. So clear? So these are the two fluxes for these two. And what do we want? Find the ratio of the electric flux passing through C1 to that passing through C2. Basically this is to this, right? So phi 1 by phi 2 will be this divided by that. So 2q by epsilon naught into the reciprocal epsilon naught by phi q. Epsilon naught, q will cancel. So 2 by phi, or 2 is to phi. So phi 1 is to phi 2 is 2 is to phi. So that is the answer. 2 is to phi is this option here. Okay. So the answer to this question is 2 is to phi. the flux through C1 is to the flux through C2 is 2:5. And finally, let us now look at this question that appeared in the JEE in 2024. Two charges, phi q and minus 2q, are situated at this point and this point, right? Find the electric flux through a sphere of radius 4a having center at the origin. In this question, the application of Gauss law is not at all difficult. What is the tricky part? Drawing the diagram. So the first thing that you must do is to draw the diagram. So let us say that this is our coordinate system. You have at 3a comma 0, you have phi q, a charge phi q. So let us say that this was 3a comma 0 and you have a charge phi q. And at minus 5a comma 0, now this is 3a, so minus 5a is going to be a little further away, right, somewhere here. Minus 5a comma 0, you have the charge minus 2q. And you have this sphere of radius 4a with center at the origin. So from here, if I draw a sphere of radius 4a, this is 3a. So 4a means it will basically be this way, right? So the sphere will look like that. And this is 5a, so the sphere will do this. This is how the sphere will look. So basically you have to draw this diagram. Once you draw this diagram, and this is the surface through which we want the flux, then the charge inside is just this one. Okay, let me show you a better drawn diagram. So here you see this is 3a, this radius is 4a. So this is going to be enclosed inside, whereas this is going to be outside. So once you realize that, then what is the net charge inside? Phi q. This does not count because it's not inside. Only that is inside. So the flux through the sphere is q inside by epsilon naught. Q inside is phi q. So phi q by epsilon naught. That's it. Actually, this is not even one step, right? The moment you draw the diagram, you can immediately answer. And so the answer to this question is phi q by epsilon naught. So you can see that there are many Gauss law questions that are asked in the JEE and of course also NEET, and they are super easy. Once you understand the concept of Gauss law and how to apply it to different types of questions, you will realize that you can solve these questions super easily. We have basically focused on one kind of question, one type of question that comes up very often in the JEE and as well as NEET. But there are many more types of questions in Gauss law and of course in every topic. Now I can't do all of that in a session like this, but I have made an entire course with 267 concept video lectures, 421 solved example videos. Okay, and of course it has a lot of practice questions, 485 practice questions. So this is the full recorded course for class 12 physics. So if you get hold of this course, you can get it at ahaguru.com. Go to the website and you can get it, or call up one of our representatives and you can get it. You will get all the concepts, all the techniques, and every question type explained in great detail. So once you understand each question type carefully, you will then be able to approach the JEE and NEET as well as your board exams with a lot of confidence, and you'll be able to do all of these questions correctly without making a mistake. That is very important. You must develop a very strong understanding of the concept, but you must also develop a very strong neural pathway for solving each problem type. And that is what this recorded course will help you do. All the best. If you like this video, please hit the subscribe button below. And if you have some comments or if you have doubts in physics or math, please write it in the comment section. I will take one of your questions and make my next video. See you all in the next video soon.